Hello, hello. Welcome to an Estes Park Group webinar series. And today we have a very special guest, Paco Nathan. Uh, Paco is presently developer relations engineer at Senzing, and he's going to help us learn about how to catch the bad guys. So without further ado, I'm going to let Paco present himself and a little bit about the presentation. Your presentation is now on screen.
Great.
And if you have any questions, feel free to add the comments on the side. We'll be monitoring that. Once the presentation's over, we'll be happy to take questions.
Great. Thank you very much, Joaquin and Steve. I really appreciate. I'm grateful for the opportunity to be able to present here. This talk is about using graph technologies in this space of anti-fraud. Frankly, the techniques that I'll go through from use cases, some of these techniques can be used in other areas. To some extent, we talk about how to find the worst criminals and the best customers in your graphs. So I wanted to qualify and say we're going to focus on anti-fraud here for a bit, but these kind of techniques can apply in other kinds of use cases as well. So the topic is catching bad guys, how to leverage entity resolution to construct graphs for anti-fraud use cases. My name is Paco Nathan. I'm at a company called Senzing. I should mention we'll have the slides. They're actually up online now. We'll provide a link to that later. Um, but just first off, before I introduce myself, just what this talk is about, a lot of it is really what's going on with like networks of dark money flows worldwide. And, you hear about sanctions on oligarchs. There's a lot of money that's crossing boundaries. We say that the money flows across a national boundary, but the laws don't. There's an estimate of maybe $3 trillion a year in terms of dark money flows, which back of the hand estimates out of all of the B2B and B2C money transfers in the world, that's about 2% of the money that's transferring worldwide. And the problem is that the kind of patterns of tradecraft, of how the bad actors hide crimes, they're hiding behind networks, they're hiding behind graphs. And because of that, it makes the cost of investigation really overwhelming for banks, which have had really a lot of banks are sort of the tip of the spear for understanding where there's potential crimes in progress. And that's been the case since the 90s. And then because of counterterrorism initiatives since the 2000s, banks are also kind of tip of the spear for a lot of that kind of investigation as well. So if you're just looking at money transfer transaction, if you're looking at those individually, like in a case management tool, it's an overwhelming amount of work to try to understand these patterns of fraud that are going on. However, when you can bring the data together as a graph and start to understand it and really understand it from more in terms of the semantics of what really is going on, who's who do we know as potential bad actors, who do we know as potentially uh, you know, politicians who've been suspected of corruption in the past. When you can start to put that all together in a graph, you can really get a kind of a lens to bring this kind of investigation work back to human scale. And so it is about really how can we leverage graph technologies to address this critical cost thing. I've heard estimates that each suspicious activity report from a bank, the handling of it costs like $50,000 per report. And with machine learning these days, you might be able to generate thousands of those reports per day, but obviously, a bank couldn't even afford to try to address that. So we need to be smart about how we handle investigation and really bring it back to human scale and have the experts working on it. And I think that also addresses a lot of problems that we're seeing right now in enterprise, a lot of different potential enterprise use cases for AI applications. But in regulated environments, you need to be accountable. You can't just throw your data at some large model and take its answers at face value. going in front of a judge with that kind of evidence doesn't work very well. So what we're going to explore here is what kinds of techniques with graphs work well in these use cases, mission critical use cases for regulated environments. And I'll be talking about mostly financial crimes, but it really does. A lot of this applies for other areas in enterprise as well. And so just the structure, we'll talk about some examples of investigative graphs. We'll look at, some contemporary AI tooling, but then contrast that with, I'll provide some primary sources, some counterfactuals in research for where there are problems in AI apps unless you're careful about how you approach regulated environments. And then I'll go into entity resolution and how this is important for knowledge graph construction, particularly when you have application areas where you must be accountable. And from there, we'll take a look at how does that feed into downstream AI apps. We've got a number of different open source tutorials and demos I can link to, but also resources. If this area of like investigative graphs, pen crime, etc., if this is interesting, there's definitely some great resources for deep dives, for open data providers, etc. And then, as far as me, against all warnings from my mentors, I chose to go into AI in grad school back in the 80s. And then, against further warnings, I was really interested in a topic that everybody said wouldn't go anywhere. It's called neural networks. So I actually worked on some projects for neural network hardware accelerators back in the late 80s and or mid through the mid 90s. During the AI winter, or wherever you would say temporally the AI winter occurred, I did a lot of network engineering, and having a distributed systems background that gave me a lot of grounding. Later on, there was friends from Seattle started calling me up with strange questions, and so I became an early guinea pig for what's now known as Amazon AWS, and I led one of the first large Hadoop instances on EC2. Our team, one of the consultants on our team, actually patched Hadoop so it would run efficiently on the cloud. And from there, I got pulled into Berkeley. Some graduate students were talking about cloud, and they were putting together a new project, and this became what's now known as Databricks. So I was at Databricks back when we all fit in one room. On and on and on. This all leads to the important part. I'm now principal developer relations engineer for the knowledge graph practice at Senzing, and we're focused on entity resolution and where this fits in with, again, knowledge graph construction and then your downstream applications. So first off, investigative graphs. And I'll introduce this area talking about especially dark money. There's been a lot published in this area, even in the popular press. There's a great movie called The Laundromat that's on Netflix, and it's got Meryl Streep as a star, but the bad guys are Antonio Banderas and Gary Oldman, and they're just fantastic. And it's a little bit of a comedy almost. It's very dark comedy, but it's heart wrenching what they're saying because it is based off of things that are happening in the real world. So that's one way to start to learn about this area. Another one, there's an excellent book called Moneyland by Oliver Bullough, who's been investigating. He was on the ground in Ukraine and Russia and all over Eastern Europe. Back after the wall fell, and he's charted out and taken a lot of personal risks to go out and invest as an investigative journalist to expose what's going on. And Applebaum and others, of course, have published a lot about this. There's an organization called ICIJ. We'll talk about them in a bit, but definitely, they did the Panama Papers, Pandora Papers, most recently Cyprus Confidential. They've done a series of investigations and publishing data about, all this criminal activity, and we'll look into some of that. One case that's become very famous and was covered in parts of the Panama Papers, it's called the Azerbaijani laundromat. And the idea is that officials out of the Azerbaijani government were apprehensive about allegations of human rights violations and corruption. And they got money out of the country. They moved it through money laundering techniques through some shell corps, 4 shell corps that were registered in the UK. And they used it to pay off EU politicians to come out and say, "Hey, Azerbaijan's awesome." But there was also some Russian arms trade involved there, and then there are also people, some of the wealthier families in Azerbaijan, who they got money out of the country through this mechanism, buying up condos and paying for university fees and luxury items, etc. Uh, and about $3 billion is known to have gone through this mechanism of the Azerbaijani laundromat. It was because somebody was a whistleblower in Estonia at Danske Bank, and they leaked 17,000 money transfer transactions. And those went out to an organization called OCCRP, which we'll talk about here. But they were able to take that data and produce it in ways, it's actually available online, it's open data now, so that investigative journalists and then criminal investigators, regulatory, et cetera, could come in and build graphs to understand where the crimes are being committed. There's a service called the Sentry, which has a nice interactive investigation of this data. So there's a network map about the Aliyev Empire. Again, some of the Azerbaijani elites who took so much money out of the country. And there's another example like this, more recent, called Cyprus Confidential. You may have seen it in some of the news headlines recently, but Roman Abramovich, well known in the UK, I believe owned a soccer team or so. Um, but a Russian oligarch had a couple of trusts based in Cyprus, and this oligarch has fleets of luxury yachts, incredibly expensive yachts. Um, and basically, what they did was they set up Shell Corps to say, okay, we're offering to sell services for people who want to rent yachts. And then he set up another group of Shell Corps that would buy. So they were just shuffling the money around. It was all basically, money on paper. Um, but they did this because they were able to avoid, like for instance, this would have been a 14 million euro VAT tax, but they were able to hide it because they had these fake customers and services. And there's even more news that's come out about this recently, that not only was he doing this with yachts, he was also doing it with his hedge funds. And so currently there's a £1 billion tax fraud fine against Abramovich, which has come out of HMRC. So this is illustrating, you can see it's a graph of how they're committing crimes. And to illustrate that, one of my colleagues here put together a illustration. We talk about burst in originators, burst in beneficiaries. In some countries, there are limits of how much money you can transfer between two parties during a period of time. And certainly, if you do a wire transfer more than $10,000, it's going to get put on the list to be reviewed. But one of the things that the people who are involved in financial crime will do is break up the funds and do multiple wire transfers coming from multiple originators. They send it through a network, and then they send it out to Shell Corp's beneficiaries, so it stays under the radar. And if all you're doing is just looking at individual wire transfers, it's really difficult to see any of this. It's not until you start to fit it together into a graph that you can actually see there's some kind of suspicious activity. Maybe there are crimes being committed. And so the challenges for investigators are, there's a lot of things that they're working with, namely the cross-border complexity. That is to say, the money flows across borders, but the laws don't. But it really comes down to the fact that there haven't been good computing tools for investigators to break through the time bottlenecks. So you can't look at 17,000 transactions and find these graph patterns, but you can build graphs and run algorithms to find some of that. So I should also mention that talking about the Azerbaijani laundromat and also Abramovich's yachts, those all happened in the early 2010s. So, we've had more than a decade since that time. And for Azerbaijani laundromat, no one's gone to jail yet. There are EU officials who brag about having been paid millions of euros and saying that they'll never go to jail. Although two former officials out of Germany were put on trial last week. So maybe. All right. So Now let's talk about graph technologies. I want to, this is a slide that comes from a colleague, Friedrich Lindenberg at Open Sanctions. And it shows essentially a kind of graph model that you want to think about when you're looking at financial crime, anti-fraud. The idea is that you've got some risk data. You could think of these as nodes in a graph, but there's risk data about politically exposed persons, corrupt politicians, etc., sanctioned oligarchs, sanctioned companies, watch lists for shell corps that have been known to engage in fraud in the past, etc. But you've got some kind of risk data. Usually that's a table. And then on the other side, you've got event data on the right-hand side, and this would be like wire transfer, payment information, asset transfers of, maybe real estate or other things. There might be, shipping, trade, or there might be some sort of log files, any kind of criminal activity, etc. But event data, usually that's highly confidential, very hard to get a hold of, because it's in-house. And then in the middle, you've got a category of linked data, which is to say, here is disclosures about beneficial owners. So here's a corporation, here are the officers, here's how much they own. If you use the link data to connect the risk and the event data, then you can get a graph to show a picture of who owns what, where the likely flows are going. So this is a model that we use for building these graphs, and data sources on the risk side. Open Sanctions has almost 250 different data sources, these watch lists that are being published, just an amazing resource. And then for the link data, there's open ownership, open corporates, ICIJ, Glyph, etc. A lot of really amazing organizations that are putting together, essentially surfacing who owns what. And like for instance, I live in California. I have a corporation here in California. As of this year, as of 2024, I've had to disclose beneficial ownership formally or risk actual felonies in California. Some states like Texas are pushing back. Similarly, in EU, a lot of countries have made disclosure, made that formalized, whereas some like Malta are pushing back. But across the world, more and more of the data about ownership is being collected. And then you've got event data. And this is usually in-house. It's usually much tougher to get a hold of. This is something banks hold on to unless there's a subpoena. Um, um, but there's an organization like, for instance, OCCRP, Organized Crime and Corruption Reporting Project. They will take leaked data from whistleblowers. Someone who works at a bank and knows that the bank is engaging in illegal activities, or someone who works at a law firm and knows that there are some kind of crimes being committed by their clients. Um, they will take whistleblowers' leaks and then convert those into open data, which can be used by investigative journalists, which can be used by criminal investigators, etc. So even though event data is hard to get a hold of, sometimes there are whistleblowers that will provide this. All right, so imagine that we've got some financial crime, we've got it organized as a graph. Of course, these days, a lot of what people are talking about in AI is graph rag. And the idea of, well, if we had a graph to help guide what we're searching for in terms of there's a pile of unstructured data, but we have some more structured uh, semantic representation, we can use a graph to help align what's going on with LLMs and help make sure that the facts are domain specific and that they follow the kind of patterns that we want to have in the results. So GraphRag is a great way to, for instance, keep LLMs from hallucinating, but really keep whatever results, information retrieval results come out of RAG, keep those consistent with your ontology, with your semantics. There's some good open source projects, Neo4j, Llama Index, LangChain, Haystack, Microsoft, etc. And also, if you're interested in GraphRag, there's a nice lexicon that shows a wide range of different patterns. I think Neo4j is sponsoring that one, but it's called GraphRag Pattern Catalog, and it's relatively vendor agnostic. Pretty interesting resource. I did an article in O'Reilly a couple months ago called Unbundling the Graph in GraphRag. If you are understanding about where knowledge graphs fit in with downstream AI applications, one of the most important things to understand up front is that the term graph and graph rag, it means several different things depending on who's talking. If you look at what Microsoft describes, they go in one direction. A graph means one thing. If you look at what Neo4j describes, they mean something entirely different. On and on. So these aren't necessarily all the same graphs. And you might want to look at it in terms of different levels of data-centric organization, how there may be really noisy graphs at one level, but then you move up a level of detail and you get something that's more organized and aligned with your ontologies. Uh, so be careful when you see graph rag. It's not so all talking about the same thing, but there are ways to apply some sense making there. However, I have been working in the field of AI for more than 40 years, and looking at what's in the headlines today, I would categorize. I'll reference Paul Pangaro with this term, today's AI, because there's a lot in the news cycle that allegedly is about artificial intelligence, but it's questionable. So I think that Ted Chiang and others have had really good commentary about this. It was a great interview with Julian Crockett at a Belly Review of Books called "Life is More Than an Engineering Problem." When you hear the term AI, I think you do want to be cautious about who is the speaker. Have they taken billions of dollars of investment to promise you the world? And therefore, do you believe everything they say? There's great work going on in AI, but there's also a lot of FUD. So I want to show just briefly some articles that are going in and providing excellent counterfactuals to sort of these dominant narratives right now that are coming out of deep pockets. This is from Gail Veracqua and Sasha Luciani and Meredith Whitaker. Gail is one of the principal people for scikit-learn, very popular machine learning library in Python space. And what they've done here is to show, actually, if you look at the use cases where large models are being applied, you do see diminishing returns, as one would expect, even though the big tech story about LLMs is that there are scaling laws and just throw more compute, more resources at them, they'll get better and better. The reality is there are diminishing returns. And this is explored in very thorough terms, I think, in this paper. There's a great article recently by Ines Montani, who's one of the authors of Spacey, very popular natural language processing pipelines in Python. I use Spacey for so much of my work. Ines talks about some of the history lessons from the whole development of the web and the internet, and what this can really teach us about where we are now. How can we parse what's going on in AI? I think there's excellent caveats there. There's also an interesting research that was sponsored by Bosch out of U Mannheim. Do LLMs really adapt to domains? And the idea is LLMs are very good, language models, large language models, are very good, as you can think of them as syntax engines. So they're doing things like learning sequence to sequence patterns. They can do diffusion techniques. There's a lot of great things that LLMs can do, largely about summarizing or diffusion. Um, but when you want to try to apply LLMs and have them tied down specifically to particular domains, that's when this whole part about generating across many different domains and how LLMs have been trained on so broad information, trying to tie them down to the specific semantics of a given domain is where they tend to fall apart. And so this is really interesting research into exactly how those kind of mechanisms, where the failure modes are. And also, shout out to a friend of mine, Natasha Noy, one of the people who initiated what's now W3C. But it's a great paper. Not every AI problem is a data problem. And this came out of Google recently. Highly recommended. Anyway, there's more. What I want to drive toward is this. There's a lot of work in GraphRag right now, but I think you really need to step back, particularly from enterprise use cases where you have accountability. There's a number of concerns why you want to look at constructing graphs in terms of step-by-step workflows where there is some domain expert input and oversight at each step. We can use models, state-of-the-art models at every step to do things. We don't just want to throw it all at a black box and take the answers that come out of the black box. So I think it's really important that enterprise teams invest in curating graphs as opposed to just saying, let a large language model do that. And to that point, I work in an area called entity resolution. And so let me show a bit more about what entity resolution is and then how this applies in knowledge graphs. So there's a lot of names, deduping, record matching, reference matching, identity resolution, etc. There's many different areas of disambiguation terms that are used, but entity resolution is this idea you want to find a footprint for data objects, entities that cross different tables in your data. So if you're starting from structured data or semi-structured data, and you have a name and address for a business, can you find that being referenced in multiple data sources? And then can you start to understand, hey, is there a more canonical version of the name, more canonical version of the address? Are there some data quality issues where maybe parts of the address are wrong in one source as opposed to another? But basically, you want to merge multiple data sources. And it would be easy to do if all of our data was really cleaned up and really well structured and adhered to standards and all of it was in English. But that's not the real world. The real world is we're taking data sources where some of the input data may be in English, some may be in Italian, some may be in Arabic or Mandarin or Russian or whatever. So we really have to take into account a lot of cultural conventions when we go about deduplication and disambiguation, these kinds of activities. So entity resolution really leverages this, and you can think of it as generating a kind of backbone or foundation for organizing a knowledge graph. Because what comes out of an entity resolution, as we'll see, are really graph elements, what you can use to build your graphs. The gist of it, though, is you want to take two or more PII features from two or more structured data sources, and then we can start to connect data records about people, organizations, vessels, etc. And it's not just a matter of like string matching or fuzzy string matching. Really, you have to go in and parse the components of names and addresses and look at other features. And while you're doing that, recognize cultural norms. I'll show this in a second. But we're working across, I think, 80 different globalization contexts. There's overall, we work on an approach called entity-centric matching. And so the idea in this illustration is, say I have 3 records about Bob Smith. Are they the same person? And if a new record comes in with Bob Jones, but hey, the same phone number, same address as some of the other records, is this a potential fraudster who's trying to apply channel separation and create a new account with only partially correct information? If you were just looking to compare record to record and do some sort of string matching, you wouldn't be able to stitch these together. With entity-centric matching, what we're talking about is let's have an entity that's a kind of overlay. And we're keeping track of where these different pieces of the puzzle might fit together. We're kind of triangulating on all the entities. And frankly, we're building a probabilistic graph internally so that we can have entities over the top of data records. And in this way, we really construct a graph of the evidence, probable cause. The origins of this, Jeff Jonas, our founder, a lot of this team has been together for more than 20 years. They started out one of the early, they were working in the casinos in Las Vegas when they started out. You can think of, there are people who should never be allowed back into the casino. There's definitely like a no-fly list, right? And so they're working on that kind of problem. And if you've ever seen the movie 21, which Kevin Spacey was a star in, about the MIT card counters working in Las Vegas. MIT mathematician or math students went to do card counting in Las Vegas. Basically, the company got started fighting against that, and then spun out, went through an IBM acquisition, and spun out from IBM in 2016 and as Senzing. And our customer mix, we're about 40% of what we do is public sector. About 60% of what we do is in air-gapped environments, highly secure, regulated environments. We have about 30 people in the company. And like I said, a lot of the core team has been together for more than 20 years. And so let me show you a typical thing that happens. You'll have, let's say there's a known money launderer, Bob Jones, and he creates an account somewhere as Bob Smith, but he only changes part of his information because he basically wants to bootstrap some false identities. So, you've got a few different applications going on. And then he opens up an account here in the middle as Robert Smith, but can we triangulate across all these records? And the idea is that we're applying entity-centric learning to be able to tie in. Okay, great. We've got addresses, we've got phone numbers, we've got some names and AKAs, and so we can show evidence that okay, Bob Jones is actually the person who's orchestrating this, and that's a kind of tradecraft used in financial crime. It's called channel separation, but we can use entity-centric learning to identify it. This illustrates I studied Arabic a long time ago. My Arabic pronunciation is horrible. My apologies. But I mean, if someone were named Abdullah Gardash, then in Arabic, that might be transliterated multiple different ways into European language. If they made a pilgrimage, they might have a prefix al-Hajj. If they're, a child of someone who's famous, they might be bin Amir. There's a lot of different ways to abbreviate, but you can see there are two string representations for the same person. We can give that a high score, even though like string matching, that would fall apart. Conversely, if you're looking at, say, voter registration, this is uh, majority of voter registration in the United States goes through entity resolution with Senzing. If you look at this case of John R. Smith versus John E. Smith, those are two different people, but they're only one letter different. So this is a fairly hard problem. And again, culture gets in the way. If you look at the top, I've been to this location in Singapore. You have a confluence of different cultures. There's Malay, Chinese, English, etc. You've got two different representations for the same exact address at the top. They're very, very different. Down at the bottom, you've got two very different businesses, but they're only two letters off. So these are the kind of cases we work with, and it's really edge cases. So much of it is informed by culture and language, and you really have to understand the edge cases over time to be able to develop robust entity resolution. I'll skip that, but it's basically nonlinear cost to getting to that level of accuracy. What we do, it's JSON in and JSON out. There are SDKs in Python and Java. And it's the kind of thing where we're basically a library that's at a low level. It's written in C. It's something that can run standalone. It doesn't have to make any service calls out. It can run in a highly secure environment. Sorry, going the wrong direction. To integrate this kind of work, entity resolution, really just a few lines will get you integration in Python or Java. Again, running JSON back and forth. And I can drill down into more, but there's a number of different models internally that are working off of addresses and names, et cetera, et cetera. And as far as, we have some big name customers here, and also a very rich ecosystem in terms of partners, different OEM vendors, also ecosystem partners, and we work a lot through system integrators, and we work closely with a number of different data providers. I was mentioning about open ownership and open sanctions and others earlier. And one thing that we're just announced a couple days ago is something called Cord, where we're working with different data providers to open up slices of data that are publicly available. You can download these. So there's a slice for Vegas, there's a slice for London, Moscow, Quebec, where you can pull in multiple data sets and start to understand what's going on with, say, businesses in that area, producing graph data to represent businesses or potential fraud patterns, etc. Okay, so how does this fit into graphs? I love this quote from Abhishek Nagaraj out of Berkeley. Think of data as an imperfect map of the underlying entities. And so if we take a collection of data sets and we want to find the footprint of entities that cross those different data sets, tie them together, we're going to have an imperfect map of nodes and relations, basically how to build graphs. So we can say that we can have entity resolved knowledge graphs. That is to say, make the graphs more meaningful by repairing data quality problems in connecting the data. Or maybe there are problems which have been deliberately introduced because there are fraudsters who are conducting tradecraft. They're doing channel separation, deliberately trying to corrupt the data to avoid detection. So we're unifying across different data sources, and then you have better data quality downstream. So as an example, here's some generated output from entity resolution in Senzing. And again, what you're getting out of this is kind of like an overlay. You could use the term semantic overlay as popularly these days. Say that there's an overlay of entities that we have evidence for them based off of pointing to various data records as the points of evidence. And also, we have entities that are related to each other. We may not have enough evidence to merge two or three entities together, but we could say, hey, if you are chasing leads, whether you're hunting bad guys or looking for really good customers, if you're chasing leads, here's some probabilistic connections to other entities you probably want to check out as well. Let me make that more concrete. Well, first off, there's some great case studies that talk about how to use this in production. I'll point to. And there's excellent industry analysis from my colleague Ben Larka a couple years ago, talking about entity resolution and AI applications. But let me make this more concrete. Typically in anti-fraud use cases, you'll see something like this. You'll have, for instance, here we've taken data out of open sanctions and open ownership, and just linking it together because of string matches. Here's what should be a subgraph. Really, it's three different little cliques of data. They're not all connected. So the idea is you want to run entity resolution to try to connect the pieces, and then partition into subgraphs is a typical kind of approach. You can do like community detection, Louvain partitioning. And then from there, maybe apply some graph algorithms like centrality, basically PageRank, you could say. And once you've got that, you can start to pull out subgraphs of interest and run those through your case management tools. This is what an investigator should look at case by case. So if we just take the raw data, we end up with something like this. If we run entity resolution, then we can connect the pieces such that now when we run an algorithm like centrality, we can say, okay, Abyssine Badshah is in the center of all these shell corps. And not to pick on Abyssine Badshah, but here's something that looks somewhat suspect. And because of having this, by virtue of having this in a graph, we can highlight, we can rank, relevance rank. Okay, we should check out about money transfers going through these shell corps due to this beneficial owner, Abyssine Badshah. And so this gets back to the point that instead of looking at transactions record by record, can we work in graphs and apply some semantics? We know that Abyssine Badshah is an individual. We know that Wilhansia Healthcare is a corporation. We know about types of relationships between them, whether being director, owner, shareholder, etc. We can leverage those semantics and entity resolution to really shine a lens on the interesting parts of the graph. And if you want to drill down, then you can use tools like why and how to do some exploratory data analysis. Like for instance, if I drill down on Abyssine Badshah, you can see here's his records coming up out of multiple sources. Here's his addresses, how they're aligning, and other data that we have about him. And this is typically a view that you would have from case management tooling, or if you're going through an audit. Okay. The next part here, I'm going to go through pretty quick because there's a lot of detail. It's probably beyond the scope of this, but I have a larger deck this comes from, and I just want to represent what's going on with graphs and any resolution for downstream AI apps. So first thing, if you've worked in natural language, you've probably heard terms like entity extraction or named entity recognition. NER, named entity recognition, is where you're extracting entities from unstructured data. You find where the noun phrases are, and you apply labels on the noun phrases. And so you make entities out of them. That's on unstructured data. Entity resolution is where you're looking for a footprint of entities across structured data sets. So you're building up evidence. And so that's working on structured data. Entity linking is where you can pull these together. You can pull what you've been able to get out of your structured data with entity resolution and what you've been able to extract with parsing NLP out of your unstructured data. You can pull them together with entity linking. And there's also a term RE, relation extraction, where you can start to infer semantic relations on the edges, on the links between data. And so in practice, we see, like for GraphRag or for agents downstream, this is kind of a generalized view of architectures where you've got some structured data sources, you're running entity resolution. You may do that in terms of ETL, or you may get updates on your data, and you may have an iterative loop, but you're basically applying that kind of overlay into your graph, and building from your ontology and then pulling in your data records and then running a semantic overlay based off of entity resolution on top of it. Then at the bottom, you're taking unstructured data sources, running them through, say, a vector database, right? You've got an embedding model. But the other thing you can do with your unstructured data is parse it, run named entity recognition, and run entity linking to tie into your graph elements. And that's really what you want to do for GraphRag, because then at the end, you end up with a graph database and a vector database, and all the pieces are cross-referenced. And the point I want to make is that entity resolution has a secondary application. Once you run entity resolution across your structured data, effectively you're generating a kind of thesaurus. The results, linguistically, the results look like a thesaurus. You can use that to train entity linking to be able to tie together your structured and unstructured data into a knowledge graph. And that's where you can really get some power, some leverage on this. And then when you go to use it, a typical graph RAG application, you get a prompt. The prompt can go through the vector database side or can go through the knowledge graph side. But at the end of the day, you're trying to apply techniques to be able to come up with a ranked index of chunks that you apply to an LLM and to get your response formatted. So what we're saying here is, how can we really make the most out of the graph part of this equation? And this is in my O'Reilly article. We've published some open source tutorials to describe it as well. But basically, we're unbundling the process of constructing a graph so that we have a curated knowledge graph that is accountable to the semantics, the ontologies you're working with. But you're also able to tie in the unstructured data. And just an example, here's parsing a sentence. You come up with some entities. There is a tool called Gliner, which does named entity recognition. It's a zero shot, which means you can change up the particular schema that you're looking for at runtime. You don't have to fine tune it. Relation extraction is an area. This is where you're looking at entities that co-occur in unstructured text. What's a possible semantic description for the relation between them? This is still kind of a research area, but there's some tooling for it. Entity linking, though, is a really interesting part to try to pull together structured and unstructured data results. And I'll reference Louis Guiton did nice work with Pandora papers, ICIJ data, running Senzing entity resolution, taking that thesaurus perspective and using that to build an entity linker based off of LensDB and Spacy. And that's all open source if you want to check it out. It's a really, really interesting project. There are ways of constructing graphs out of raw text. I've been involved in that for several years. We can go into that in more detail if you want. There's some great open source. There are ways of applying different types of semantic random walks and other graph algorithms on these kind of graphs. There are some interesting tooling now to test graph quality as you add more data. I'm pretty interested, particularly using probabilistic soft logic and others. And just at the end of the day, it's tooling for how do we build up a graph. So I want to close up soon because I want to leave a lot of questions, time for questions. But basically, we have a few online tutorials. Here's a quick start if you want to try using entity resolution. Here's a Docker-based quick start. There's also a Linux quick start there if you have a cloud instance you want to run with. and there's some tutorials for entity resolution with knowledge graphs. Um, here's one that I worked on last year. We were using data from Department of Justice and U.S. Chamber of Commerce. We were looking at PPP loan fraud by businesses in Las Vegas, where there were some really egregious examples during the pandemic. And so we were using open data to spot patterns of fraud. And then my colleague Claire Sullivan, she took that same case, the same data, and applied GraphRag using LangChain so that you can use a chatbot to explore potential fraud cases within your graph. Both of those are open source on GitHub. And here's a talk that I had showing about how to do an unbundled approach to knowledge graph construction from unstructured data. And then Louis Gouton, here's an example that Louis did with Spacey and Gleiner using Senzing entity resolution to train in a domain-specific entity linker, so that when you parse a journalist's article about the Azerbaijani laundromat, the entities, the Aliyevs, one of the oligarch families, they're automatically linked into your knowledge graph, right? Just by virtue of having that entity linker, you automatically pull from unstructured sources directly into your graph. So you're using the graph with entity resolution as a kind of backbone to organize your graph. And if you're interested in getting involved in this area, Open Sanctions, there's a project called Follow the Money. They definitely need help from data professionals. Open Ownership, working on beneficial ownership disclosures, also definitely need some help there in promotion. The whistleblower organizations like ICIJ, OCCRP, they're looking for people to help them. If you want to dig deeper into this, there's a few areas of certification you can get, for instance, in human trafficking, to understand really what's going on there. And I'm also involved in an organization called Graph Geeks, which is vendor neutral. It's really people who are practitioners in graph technologies who want to talk about techniques, and we have a study group about investigative graphs, and some more community resources and conferences. And I do a webinar every month with graph experts talking about resolution and these kind of use cases. If you want to join us, and definitely link up with me on LinkedIn. And let me turn it over to questions.
Excellent, excellent. Thank you very much, Paco. Always a pleasure to hear from you, learn from you, and see what you have cooking. So we have a few comments. I'm just going to start with Jenna Jordan. She says, love that Ted Cheng interview.
Yeah, it's great. I really, there's a wealth of insight and helpful guidance, I think, really from more of a philosophical approach, but going back to some first principles I think that is just Ted's work, and particularly that interview drills down on it. Okay, question from Patul.
More a comment. You might like this quote: a wonderful harmony is created when we join together the seemingly unconnected.
Wonderful.
Heracles.
Wonderful callback to Abhishek's quote too, the one I had from Berkeley House. Fantastic. Jenna had a question. Jenna Jordan in the same. Yeah.
In the same way that we actively curate and manage tabular data in data warehouses or otherwise, is this a way to actively curate knowledge graphs or knowledge bases over the long term, with people inputting the results of their investigations to resolve suspected entities? Or is this more one-off with data and
Great.
process in them potently and then having data out?
Fantastic. Thank you, Jenna. And hi, Jenna. This is a question I've actually heard in multiple customer conversations over the past week, because there are cases where it's just a one-off, right? Like, for instance, if you're working in legal and looking at e-discovery, maybe you're just developing that graph to answer some questions for that phase of discovery. You put it together, answer questions, you're done. So it's not something you could really curate, right? Because it's very time dependent and specific. But generally speaking, if we're talking about financial crime, we are talking about shell corporations. These are incorporated entities that have some disclosure. They're chartered in some country, and also the patterns of fraud are temporal. They happen over time. You don't just take $3 billion and push it through, and the next day, buy your condo in Manhattan. It's a kind of tradecraft, a kind of crime that's committed using a network where patterns happen over time. So yes, we're actively curating. The nature of investigation in general is iterative. And if you look at basically any crime drama on TV or any movie about investigations, like going back to Homeland or NCIS or whatever, the protagonist ultimately has a wall in their apartment and they've got pictures tacked up and news clippings and there's red yarn stringing from one to another. They build a graph on their wall. And similarly, when you talk to the enterprise team about how their business works, you put them in front of a whiteboard, I guarantee 9 times out of 10, they're going to start drawing graphs. So we do think about this kind of iterative approach to curating knowledge graphs, and in the investigation space, that's typically what's happening, because you find some connections, you do some more investigation, you get some better data. Maybe you have to unmerge some entities. Maybe you had Robert Smith and Bob Smith, and then you see it's Robert R. Smith and Bob E. Smith. So you might have to split some of what you have. So there's definitely a lot of curation and domain expertise that goes in. What we're saying is that we can take our overarching semantic definitions, our ontology, to really ground the shared definitions for what we're building. And then we can use entity resolution to try to tie into those ontologies, the parts. Here are people, here's an officer, here's an intermediary, here's a beneficial owner. And then we can bring in mountains of other data to try to tie it in where it might work. The point, though, is to be able to leverage graph technologies to take that 5 billion node graph with many gigabytes of data and split it into subgraphs that might only have 20 elements. And the investigator needs to go look, for that case, at those 20 elements. So it's kind of shining a lens using graphs to go from the very large down to the small. It's kind of a data engineering problem for dimensional reduction, if that helps.
Hey, Paco, you mentioned the underpinning elements of a ontology and how that can really be an important aspect. I mean, in your experiences, what ontologies have you found to be effective to be part of that implementation?
Great, fantastic. Well, so that's what I was mentioning about Friedrich Lindenberg and Open Sanctions. They have a project called Follow the Money, where they are putting together a relatively comprehensive, generalized ontology for fin crime and for chasing transnational corruption.
It's open source.
Yeah, and that's it. They're looking for help. They're looking for partners. They're journalists, and they've found their way into data, and they've found their way into graphs, and now they're saying, "Is there anybody that can help us?" So I think that's a great way to get involved. But also, I would like to see those
Joaquin, can you pull that slide back up again? Or there you go. You
are
right.
Open Sanctions, and then Follow the Money. They have some links on there too. But that's an example. If you go to an individual bank, they'll be using techniques like this. A given bank in their fraud response team might have their own customized versions of this because of how they define things within the bank. And I've seen those. I can't. Those are proprietary, so I can't talk about them. But I was in a forum recently where multiple banks were showing some of their ontology work for that. Very important. And the reason why ontology is important is because when an incident is happening and you know that something bad is happening, say over on this server and this server, you know they got into the bank somehow, right? So there's a missing piece, and the ontology can tell you, wait, there's some information, we don't have the full pieces of the puzzle yet. We know that there was a vector of attack. We have to find that, and we have to stop it. So ontology is your guide for unraveling all the details in an investigation. Does that help?
Absolutely.
I think there's a natural question that goes further into that vein. How is relation extraction different from entity linking?
Okay, great. Just in terms of normal human discussion, like if we had a transcript of our discussion here today, we're asking some questions, we're going back and forth. As people are talking, you look at a text, you look at how texts are organized in terms of like sections and paragraphs and sentences. There will be references to things, like if we were talking about Polex as a shell corp for money laundering, multiple speakers might be talking about it. So it'll show up multiple times within the text. So the idea is that named entity recognition, NER, is where you extract from unstructured sources. Entity resolution is where you extract from where you find a footprint across structured sources. But once you have identified that there are some entities, if certain entities happen to show up together a lot, if they're co-occurring, next thing you want to ask is, what's the relationship between them? Why does Abhishek Badshaw keep transferring money into this company he owns part of called Wellhansia that transfers money into a company his wife owns? So that's where you start to look at relation extraction. And you start to say, hey, I've got two entities that are co-occurring. What's the relation between them? Let me see what kind of semantics I can start to apply from my ontology. Like I don't want 500 different relations defined. I would like to have a smaller set of well-known, well-defined relations where the domain and the range are specified. Like basically the source and the destination have different types. There might be, for instance, shareholder. So, you might go from a source is an individual and they're a shareholder into a corporation. So the domain is a person and the range is corporations, things like that. So that's why relation extraction is different from entity linking, because you want to be understanding the co-occurring entities. Entity linking is really more about, I have some kind of knowledge base or some kind of graph that pre-exists. I have some parts of that graph that are extremely well defined. These are definitions out of my ontology that we're all agreeing on, possibly because of legal reasons or regulations. And then there are parts that come from validated sources. We think we understand that backbone of the graph, but then there's other parts you're trying to tie in. So the question is, if I have some parts that I really trust and understand, and I have a lot of other parts that they're kind of iffy, but where would they most likely fit given my domain specifications? That's where entity linking comes in to say, well, we don't have evidence to exactly tie Bob Smith and Robert Smith together, but we think that since they happen to have the same phone number and live at the same address, they're probably, well, that's a clear case. But I mean, if you have a probabilistic linkage, that's where entity linkers come in, and they're models basically.
I'm just going to jump very quickly to the last question, and then I'll go back to a few other questions. I have one comment to share with you.
Great.
Thank you for this webinar from Jenna. Will we get slides and recording after? For recording, yes, of course, we're going to make this publicly available. But for the slides, is that something that you are comfortable sharing, Paco?
Yes, most certainly. I had a link for the slides earlier, and I don't know if I can actually enter in here. I can put it in private chat, and then if you can, here's my slides. I'll put in private chat, and if you can copy that over into comments.
Well, I'm happy to. Let me see.
Thank you. Yeah, I think I've made a couple last minute changes on this. We were preparing last night, so I will get the new almost everything is there, but there's a couple slides that had some new information added, so I'll add those later today.
I wanted to say thank you for demystifying the difficulty in resolving entities between a multitude of heterogeneous data sources. You have the relational databases, like what Jenna was saying, things that people put in relational tabular ways. You have news publications, what comes out in the media. This person got in trouble for this thing, or this person is suspected for that other thing. Social media, anything that comes out of that, and whistleblower documents. Those are all different sources of information that you need to reconcile through that ontology, right? That entity linking that you were describing earlier. So, and to deal with another layer of complexity, everybody's wearing a false identity, right? Like, did they change their name? Did
they're trying to hide?
Put a shell company.
Exactly.
You wrench into things.
You've got this whack-a-mole problem, and as I mentioned, I'm showing about fin crime and examples from fin crime and use cases that we have from our customer base. This same kind of thing can apply for complex supply chain analysis. Like if you've got certain shipments that are coming from a different part of the world and they're transiting, they're on the boat, but then maybe a war breaks out. And so can you get news reports that might give you a leading signal for the fact that some of your critical shipments are in trouble, there's supply chain problems? This is another way where you can really leverage a knowledge graph and leverage the semantics to understand what's going on out of those regional news reports.
Please reach out to Paco Nathan, connect with him on LinkedIn, and reach out to Graph Geeks as well. They're an excellent community ran by Amy Hodler, and who's the co-organizer?
Dennis Inarare.
There we go. So,
Right.
Steve, do you have any last minute questions? I know we have two, but Pierluigi, I recommend you reach out to Paco. We're running out of time.
Yeah, yeah. Just short, you can think of PSL as a kind of a probabilistic measure. When you create a graph, you can get a consistency measure based off of rule sets that you have for the relationships. And then as you add data, you can take additional consistency measures. So you can think of every time you update the graph, you can measure, have I dropped in consistency? Therefore, I should probably look at the new data elements and see if there's errors. Also, you can get probabilistic measures on each element. Is it an outlier? So it's a way of having a kind of unit test that actually focuses on outliers for graph elements.
Hey, Joaquin, to close up here, I know that we went to a different format. So if anybody is still on, please provide some comments in regards to whether you like it, whether you didn't like it, what can we improve, just to give us some feedback. Appreciate it.
Wonderful. Thank you both very much. I really appreciate it.
Thanks, Paco.
Thank you, Paco.
Okay.
Thank you, everybody.